Welcome and thank you for joining us today for Network Visibility Architectures for the Hybrid Multi-Cloud Enterprise. My name is Raleigh Gould and I'll be the moderator for today's event. Our featured speaker is Shamus McGillicuddy, VP of Research covering Network Management at EMA. Shamus has more than 16 years of experience in the IT industry as an industry analyst and journalist. His research focuses on all aspects of managing enterprise networks. And before I hand things over to Shamus, I wanted the audience to know that he will be concluding his presentation today by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, Shamus will be providing more information on this new research report, so find out more when you get the follow-up email. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thank you, Raleigh, and thank you everyone for joining me today for this webinar highlighting new market research from me at EMA. Before I go any further, I just want to acknowledge and thank the sponsors of this research. As some of you who've attended webinars like this in the past with me know, I conduct a lot of independent market research, usually at least once per quarter, on the world of network infrastructure and operations. That research is proposed and led by me, but it is made financially possible by the people who choose to sponsor the research. And in this case, Gigamon and Keysight, two leading vendors in the network visibility space, made it possible. So thanks to them for being on board with that. In terms of an agenda for today, I'm going to talk briefly about my research goals and methodology, just so you know, you have context for the data and the analysis that I'm going to go over in this webinar. Then I'm going to talk about enterprise network visibility strategies. Like, why are people spending money on this stuff? What are they, what's driving that? How successful have they been with it? Then we'll look at visibility architecture, the actual approach they have to establishing a network visibility solution that delivers packet data to their analysis tools. And then we'll look at how, finally, we'll look at how the cloud is impacting that. When you move a lot, you may think of a network visibility architecture as a series of taps and span ports and packet brokers and hardware and maybe some software that lives in your on-prem environment, and you move stuff to the cloud. Like, is network visibility still relevant? So we'll answer that question, and then we'll end it with a Q&A session at in the conclusion of the event. So in terms of research goals and methodology, let's just, what are we talking about here, just in case there are any novices to the subject. This is new market research on the concept of network visibility architecture. EMA has been conducting research on this topic for close to a decade. Usually every 2 to 3 years, we survey industry, IT and security professionals about their use of these technologies. And so what is network visibility architecture? You can think of it maybe as an overlay of traffic mirroring, traffic aggregation, and distribution of network data that delivers that data, usually in the form of packets or some derivative of packets, to the tools that companies use for security analysis and performance analysis, maybe compliance tools, think like network, packet-based network performance management, application performance management, intrusion detection, things like that. The key components of such an architecture, it starts with the mirroring technology, the taps and the span ports that people use to mirror traffic data off of the production network, or in some cases, they might be doing inline stuff as well. But mirroring the traffic and sending it to aggregation devices such as a network packet broker appliance or a lower end device that is not as full featured as a network packet broker appliance, which then aggregates filters, forwards traffic. But it also includes a lot of other components that are not hardware-based, such as software-based probes and software-based or virtual network packet brokers that can be used to help you get traffic off of virtual infrastructure. And similarly in the cloud, you might be using cloud-based probes and packet brokers, cloud-based packet broker software, or you might be using the traffic mirroring services offered by cloud providers, which they've introduced over the last couple of years. And just here, in terms of, why you want to invest in this stuff, I interviewed a handful of practitioners in addition to a market survey, just to enrich my analysis. And I just asked them all, why do you think this stuff's important to your company? And this guy kind of put it eloquently. You can tell that he has his pilot's license, this enterprise monitoring systems engineer at a Fortune 500 healthcare provider, says that network and security operations is like flying in an airplane. Flying an airplane in good weather, visual flight rules are fine. There are indicators of network health and network security that sort of bubble to the surface and are easy to see with less granular data. But when, as he says, the storms come up and you're going to need deep instrumentation and, as he calls it, instrument flight rules. Otherwise, you crash. It's all good until it's not, and then you're in the wilderness. Like, what happened to my network? I don't know why it's down. I don't know why all of my data is out in the public sphere. Packets are usually the best way to get answers to those questions. In terms of goals and methodology, we wanted to identify best practices and emerging requirements for this technology. What's guiding people's investments and their use of packet brokers and taps and software for getting packet data to their analysis tools. And we wanted to do that in the context of several key drivers, such as the ubiquity of virtualization and east-west traffic patterns in data centers, the proliferation of hybrid multi-cloud architectures, because EMA research finds these days that the majority of enterprises have started to be multi-cloud and expect to be very multi-cloud in the next few years. And increased use of encryption to mask malicious activity by malicious actors. So we'll get into that a little bit in this research. In terms of methodology, in addition to the handful of practitioners that I interviewed one-on-one on the phone, we also surveyed a little over 300 people in IT and security teams about their use of this technology. These are the demographics. First of all, we asked them qualifying questions. We asked them, please describe your engagement with the technology. They either had to tell us they evaluated and selected, procured and implemented, maintained and or used this technology, or provided executive management of teams responsible for that stuff. If they had none of those on their resume, they were kicked out. They also had to have a network packet broker installed. I just felt that was like a baseline that, if they didn't have a network packet broker installed in their network, chances are whatever they describe as a visibility architecture is not very substantial. In terms of who these people were, about half of them would be like IT middle management people or security middle management people, the words director, manager, supervisor in their title, and then the rest of them were split between technical staff like architects, engineers, and IT executives. In terms of functional groups, you see the technology executive suite kind of lines up almost perfectly the number of people who say they're an IT executive. And then you see a lot of other people were either cybersecurity or IT security or risk management types or project management or program management. And then you see a sprinkling of other operations and engineering types, either in cloud, data center, or networking. Good mix of company size from the mid-market up to very large. Transatlantic view is usually what I do in this research. So in North America, it was mostly United States, but also a significant number of Canadians. Then in Europe, it was a nice mix of the United Kingdom, France, and Germany. And then in terms of industries, you see a nice mix. I think roughly 12 industries represented overall, but these are the ones that are most commonly seen in the survey. So in terms of visibility strategies, 78% of the companies represented in our research told us that they're increasing their spending on network visibility architecture over the next 2 years. and a little less than a quarter of them described that growth as significant. So, not just like a 3-4% increase in spending, but maybe 10, 15. We didn't get into numbers, but there seems to be a decent number of them, a quarter of them, who need to ramp up their spending significantly. And we saw that group of people who were the people who told us in a separate question that they were the most successful with their overall use of network visibility solutions were more likely to report that they were expecting to grow significantly in their spending, which tells you that if you use this technology well and you demonstrate the value of it to stakeholders, CIO, CISO, and his or her direct reports, there's going to be interest in expanding that spending if it's going to deliver real value to the business. So it's important to keep that in mind as you're, you want to, you don't want to, when you're implementing a solution, you don't want to do good enough in something like this. You gotta do, best of breed. You need to, optimize and develop a best-in-class network visibility architecture if you want support to continue to maintain it and grow it and protect your business. What are the key strategic drivers of that spending? The top three are on the left here. Hybrid and/or multi-cloud architecture is reported from a majority of them. The cloud is, the cloud is not making network visibility architecture solutions less relevant. It's making them more relevant. It's driving their spending. Zero trust security, and nearly half of them pointed to that. And then you see application performance optimization, which may overlap to some degree with the cloud stuff. They need to optimize their application performance. Maybe that's because it's moved to the cloud and they need to find ways to improve its performance, or maybe it's not. Maybe it's always been in the cloud, or maybe it's still on-prem, but they need to improve application performance. And they see a network visibility architecture as a route towards that. We also asked them about reactive spending. Were there any events or issues that you've experienced over the last 2 years that prompted you to invest in visibility solutions? And 97% of them identified at least one thing that had triggered spending in that time period. Traffic growth was number one. And that was interesting because the last time we asked that question in 2020, it was the number 6 response. So traffic growth has become top of mind for the people that own this technology. They are finding that the amount of data coming out of their network that they need to analyze is increasing. And they need to keep up with it to protect the ability of their tools to be able to analyze that traffic. Like their security solutions, their performance analysis solutions need to keep a handle on all this traffic as it grows. And how do you do that without having to spend millions and millions of dollars on analysis tools that can handle higher flow rates of data? Well, you do that by optimizing filtering and optimizing the data before it hits the tool. And that might be the most cost-effective way to handle that. And that's what you see is happening here with 44.7% saying it's driving their spending. The secondary ones have not changed in terms of order for the most part from 2020. It's still network complexity and risk assessments prompting spending, and then a security breach and infrastructure upgrade, and new investments in security or performance analysis tools that drive the desire for access to packet data. Those are the big secondaries. And this information security engineer at a managed security services provider sort of says something that's somewhat self-evident, but still bears repeating. He says unauthorized access to a network can lead to so many serious problems for an organization. If you have tools that require packets, those tools will definitely need visibility into the network. Network packet brokers are one of those things that you must have for full security. What does that mean? Like, you can't have an ad hoc approach to getting traffic data to your analysis tools. You can't be reactive. You can't say, well, okay, so I think something's happened. I'm going to go and physically tap into the network here, do a packet dump, and then do some forensic analysis. No, you really need to be instrumented to have full visibility at all times. You need to have the lights on. You can't turn the lights off to save money and then turn them on when you need to see what's happening. Um, Only 34% of the organizations that we surveyed in this research told us that they were fully successful with their overall use of network visibility architecture. And that was down from 40% in 2020, which is concerning, but I've seen that across the board. Overall, I've seen over the past 4 years, anyone who's involved in like network infrastructure and operations are telling me that their overall effectiveness is degrading for a variety of reasons. Like there's just a lot of there are a lot of disruptions to how people build and manage their networks these days. Number one being the cloud, and it's making them feel helpless to some degree. And you see that sort of trickling down here. Um, when you ask them what their biggest challenges are with using network visibility fabrics, the two big ones are scalability issues and architectural complexity. Now, you think about scalability issues, that kind of kind of takes you back to you know, why are they spending? Traffic growth, right? So scalability issues, they're having trouble keeping up with traffic growth. Scaling up their visibility architecture is a heavy lift in some cases. They're trying to keep up with that traffic growth, so they're spending more on these architectures, and it's sort of a race to keep up. Hopefully they'll catch up, but traffic growth never seems to go down. So it is it is an ongoing race, I think. Architectural complexity also a big one. So, this is an issue of them not having a full end-to-end understanding of the intent of their network and the state of their network, which can guide how they instrument the network with a visibility architecture. Like, where do I need to get traffic mirrored? Like, where do I need to mirror traffic to my analysis tools? Do I know all the parts of my network that I need to be doing that on? A significant number of them are telling us they don't. And then data quality. Maybe this can be related to scalability issues where they're dropping lots of packets because they can't keep up with traffic growth, or they may have just implemented the solution poorly, and so they're not getting good data quality. Or it might be a question of maybe they're relying more on spam ports than taps. We'll get into that in a second. And then skills gaps, budget issues, limited cloud visibility are the tertiary issues here. On the left, you see the benefits of using this technology. Like where's the payoff come? Where's my ROI come from? The two big ones are productivity and reduced security risk. It's hard to put a dollar figure on the second one, but on the first one, it's very easy to. If you are boosting the productivity of your IT team and your security team, you can demonstrate to leadership how that has freed up full-time FTE hours with valuable engineering resources. We're paying each of these people six figures, and they were spending so much time, just making sure that the data got to the analysis tools that it represented $1 million a year that was wasted on this. And now that we've invested in network visibility architecture, we've installed it, and we've freed up 500 hours a year or 1,000 hours a year of engineering time because we're no longer reactively getting that data. The data is just there and it's going to the tools. We don't have to do all this heavy lifting to get the tools the data that it needs. That is the improved IT security team productivity, and that is a major driver of ROI. The reduced security risk, I mean, if you can demonstrate the value of not having a breach, then that can be a huge opportunity. But yeah, just there's just the peace of mind of knowing that you've reduce the amount of security risk on your network, that you don't, your blood pressure goes down up and down the organization. And then you see the secondary benefits here, pretty good, like improved capacity management, optimized cloud migration, which is driving a lot of spending here to begin with, and then network and application performance and resiliency, all great opportunities. So let's look at visibility architectures. Getting back to taps versus span ports. So enterprises, this shows you 4 years of data, 2018, 2020, and 2022. We asked them every 2 years, what percentage of port mirroring on your network is accomplished via span ports versus taps? Now, what's a span port? That's, what is that? Well, I can't remember what the acronym stands for in a sec for this for the moment, but it's basically configuring a switch so that one of the ports on the switch becomes a traffic mirroring service that you can forward to your visibility architecture. Now, a tap is a physical device usually. It can be a virtual device in many instances actually, but when we're talking about the physical port mirroring, a tap is a physical device that is is mirroring traffic from the production network without asking the switches on your network to do that work. And there are a variety of benefits for that. But what we're seeing is the majority, most enterprises accomplished in the past the majority of their port mirroring via taps rather than span ports. But there's been this swing more recently of them relying more on span ports rather than taps. And there are implications for that, which I'll go over in a second. But one thing you see is there's a higher percentage of span port use among the largest companies in this survey, which tells you that perhaps network complexity and cost is driving this. As larger companies try to mirror more points on their network and improve overall visibility, they're relying more heavily on span ports because it might be a cheaper approach in terms of CapEx spending, but there's an OpEx flip side to that. What are the challenges of using a span port? Well, we can look at it through the lens of the key benefits of using a tap rather than a span port. So there's reduced management complexity. When you're using taps, those taps are from a vendor that specializes in visibility and has usually and is also probably a network packet. Your network may or may not be your network packet broker vendor as well, and specializes in providing software that manages those taps centrally. So you can manage change controls, you can manage moves ads, you can you can prevent unauthorized changes. You have visibility into everything that is configured on those taps, and it reduces operational complexity. So that is the benefit of using a tap, but it's on the flip side, you may not have a central view of your span ports configured on your various switches across the network. And so that means it's very hard to manage change and enforce unauthorized changes on your visibility fabric at the traffic mirroring layer. The secondary benefit of using a tap is data quality. And what's that? Well, these taps are optimized to deliver mirrored traffic to your visibility architecture, whereas span ports are best effort. A switch's main job on your network is to receive and forward production network traffic. Secondarily, or maybe even in a tertiary profile behind other things like security and things like that, is mirroring traffic through a span port. If a network switch is experiencing high utilization, it is going to withhold resources from that span port in order to fulfill its primary mission. And that span port will start to drop packets, for instance. And that's going to impact your data quality. And that's why people invest in taps. And that's why it's a little troubling to me to see a lot of people relying more heavily on span ports in recent years. And then reduced hardware resource utilization is the least important benefit of using taps, and that's kind of the flip side of data quality. Like you're asking less of your infrastructure to support your visibility architecture, and that's that will reduce the risk that you're maxing out resources on your switches during times of high utilization and so forth. Virtual infrastructure. So 98% of the organizations in our survey told us that they were mirroring traffic directly from virtual infrastructure because, as you know, when you virtualize infrastructure, there's a lot of traffic going back and forth between virtual elements that may never touch a physical port or interface on your network because it's all happening in a server or something, right? So what kinds of virtual infrastructure they're mirroring traffic from? The three big ones are virtual servers or switches. I'm sorry, virtual servers, virtual storage solutions, and virtual switches or routers. And then almost half of them said they're mirroring traffic from cloud native platforms like containers using something like a service mesh or something. So whether that fourth one, the cloud native platforms, is integrated into a virtual into a network visibility architecture may vary. Some people that might still be siloed. A lot of people that might still be siloed from the rest of their solution. Only 34% of organizations told us that their primary approach to mirroring traffic from their virtual infrastructure was the native traffic mirroring capabilities, like a virtual span port of their virtual infrastructure. The majority of them preferred using a third-party tool, like a virtual network packet broker or TAP or something like that. As we mentioned earlier, like everyone in the survey is using has network packet brokers installed like in their network. These are the platform requirements they told us they have in terms of product requirements in general, but the platform requirements that they're really interested mostly in advanced features and resilience and reliability of their platforms. Secondarily, they're worried about manageability and the scalability and performance of those platforms. In terms of the advanced features, the critical packet manipulation features are really about data and data generation features are really about generating a couple of types of data. Like they've recognized network visibility vendors as a good source of threat intelligence. Some of the vendors in this space have started offering, have built up their own security research teams that provide threat intelligence feeds, and the people who are using network packet brokers solutions are welcoming that as a key critical feature for their packet brokers moving forward. They also see decryption as important, the ability to decrypt traffic so they can forward unencrypted traffic, decrypted traffic to the analysis tools that need to see the payloads in the packets. And then packet metadata generation or net flow generation is very important. And then in terms of packet manipulation, besides decryption, packet slicing is quite important to them. And then in terms of filtering, the biggest one was being able to filter traffic by layer 7 application information. That was their biggest priority. Secondarily, they're interested in filtering lower down on the OSI stack at layer 4 and regular expression filtering, deduplication. Those are lower priorities, but still of interest to a lot of the people in this survey. Now, visibility architecture enables inspection of encrypted traffic, which is becoming increasingly difficult, but is very important. Encryption is becoming ubiquitous on networks today, and in our research, when we asked them to estimate, how much of the malicious activity that you have detected on your network over the last year was hidden within an encrypted packets, the mean response to that question was 27%, and that. But that doesn't sound too high, I guess. But the more successful people were with their use of network visibility architecture, the higher that percentage went, which tells you that people who are not doing so well with their implementation of this technology are not seeing as much of the malicious traffic as they should be. These are the people who told us that they were successful with their use of network visibility solutions reported that 34% of all malicious activity on their network was in encrypted traffic, whereas people who were just somewhat successful reported that it was down at 23%. So that's a pretty big gap, and it tells you that network visibility architecture is essential to detecting malicious activity, in my view, that it's hidden within encrypted traffic. However, a lot of people aren't doing it. Like when we ask them, what's your preferred resource for decrypting TLS and SSL traffic for inspection? The most popular response was right on the tools, the security and performance analysis tools. which is not ideal because that really impacts, well, first of all, it sort of silos your decryption. Some tools might be better at doing it than others. Um, and it takes a lot of resources away from those tools in terms of their ability to actually analyze the traffic once it's decrypted. It's not efficient. And actually, it was less favored by people in cybersecurity. People who are responsible for security analysis tools don't want to do this, basically. Um, the second most popular approach was to do it on the network packet broker, which I think is an ideal spot for it. Another 12% have just a dedicated decryption appliance, which is good, but it might add some complexity to overall management when you're doing it on a standalone device. That's just one more thing that you need to manage. 11% prefer to do it on a packet capture appliance, which is usually plugged into a network packet broker and just recording everything that comes off of it. And then a small percentage told us they're doing it on an application delivery controller, which um, obviously not preferred, but there's some people doing it. All right, so the cloud. What's happened? What is happening with the cloud? Oh boy. So first off, the cloud challenges visibility. Network operations teams tell me this a lot. They are not happy with the amount of visibility they're getting into cloud networks, and they're trying to extend their solutions into the cloud, and they frequently are challenged in that regard. And here we see in this research that 45% of the organizations are experiencing um, blind spots on the network when they move to the cloud. Like the migration of applications to the cloud has created blind spots. It's more common in companies that report being multi-cloud today, which tells you as they move from one cloud provider to another, their visibility gets worse, right? Because there's no, maybe they just don't have the same levels of visibility in different cloud providers because those different cloud providers don't provide the same level of visibility natively. For one reason or another, maybe because of cost or complexity or just quality of their visibility capabilities. We asked those people who experienced the blind spot, what were the consequences? And you see the four top ones listed here. They experienced a policy violation, which may have led to someone getting fired or maybe led to a fine of some kind. They've experienced extended IT service degradation or downtime. So the applications in the cloud just aren't performing or aren't accessible because of lack of visibility. They can't proactively prevent problems. They can't fix problems fast enough once they impact the business. And then 45% said they've experienced a security breach in the cloud as a result of a cloud-related blind spot. Not good. That's 45% of the people who have blind spots, not 45% of all the companies in the survey. And then cloud cost overruns. They just can't see utilization well and can't optimize. They can't shut down orphan workloads or whatever because there's just not enough visibility to police all that. Engineers, architects, and other technical personnel in the survey were more aware of cloud-related blind spots than people like CIOs, VPs of architecture, IT director, security manager, team manager. So the closer you are to the packets, the closer you are to operations, closer you are to technical operations, the more aware you are that the cloud has caused blind spots. That tells you that leadership needs to embrace the fact that the cloud is creating blind spots, be aware that they might not be aware that those blind spots are there. And when the engineers and architects come to them and say, we need to spend on visibility, they need to listen because of security breaches, policy violations, and downtime. And packet data is critical to cloud operations. We asked them, do you think that packet data is very important is unimportant or important to these three things: cloud security monitoring and analysis, cloud performance management, cloud capacity management? 65% said it's very important. Packet data is very important to cloud security monitoring and analysis. A little more than half, 54%, said it's also very important to performance management. And then exactly half said it's very important to capacity management. So you see there the recognition that packet data is important in a variety of ways to success in the cloud. And on the left, this pie chart just shows like what are they primarily collecting and analyzing when they talk about packets in the cloud. 46% are focused on getting full packets. Almost 38% are focused on collecting packet metadata generated by those packets, perhaps through a network packet broker deployed in the cloud. And then just 16% rely primarily on packet header information. So there is a desire for deep visibility into that packet data. Most organizations perceive the importance of having an end-to-end multi-cloud visibility architecture. So building something that spans your on-prem environment and your cloud is top of mind for a lot of people. Establishing that architecture so that it spans both those environments, 33% of all organizations believe that it is very important to do this, and another 56% said it was somewhat important. When you looked at just the most successful users of visibility architectures, that recognition that it's very important to unify on-prem and cloud visibility architecture goes up to 50%. So half of all the guys that are most successful with this technology are saying that it's very important. So that points to it being a best practice to unify visibility so that you have an end-to-end view of your network and you can manage that visibility architecture across your on-prem and cloud environments is very important. What is the primary method for mirroring packet data from the cloud for security and performance analysis? Only 38% are relying primarily on the native packet monitoring services offered by cloud providers. Those services are only a couple of years old. They're still pretty immature. 60% said they really want to use third-party software like a virtual network packet broker or virtual TAP. And what's the most compelling benefit of using that third-party stuff in the cloud? Well, it's reliability of data collection. It's administrative well, that's the big one. Just you're not going to drop packets. The data quality just goes up when you're using a specialist vendor in the cloud to pull that data. Administrative security and manageability and automation are the secondary benefits. You want to have good chain access, role-based access controls in place so there isn't some sort of malicious mirroring of traffic in your cloud environment, which maybe someone might be able to do if they steal cloud credentials, which are harder to track sometimes. And then manageability and automation, just being able to centrally manage everything. And then advanced packet filtering and modification features and integration with visibility technology and private infrastructure are the secondary benefits. So final thoughts. The cloud is the primary driver of network visibility architecture strategies today. That's driving spending. It's challenging architectures. Visibility architectures improve IT and security team productivity primarily, and it also reduces security risk, and that's how you want to sell it to your stakeholders that are holding budget. If you're a network engineer focused on troubleshooting, monitoring and troubleshooting the network, and you're struggling to get network visibility architecture spending support, go to your security team because chances are they want access to packet data, better access to packet data than they have today. And you can usually get approval for spending by teaming up with them, either pooling budgets or having them go up the chain to make the case. And then you can implement it and own it. Too many organizations are leaning on span ports today rather than taps for traffic mirroring, and I think people should keep an eye on that and how that impacts complexity and effectiveness of their ability to mirror traffic into their visibility architecture. Too many organizations are decrypting traffic on analysis tools. There are multiple options for doing that are a better choice and are going to extend the life of your analysis tools. So make that change. If you're getting pushback from some of the owners of the analysis tools, just point to the value of having a central solution that is going to make their analysis tools more efficient and able to scale gracefully. Because as traffic goes up, as traffic growth continues, the overhead of decryption on those tools is going to increase, most likely. So it's going to make those tools less effective over time. And network blind spots have been introduced by the cloud in a lot of companies, and it's leading to policy violations, IT service problems, security breaches. You need to be rigorous in how you approach visibility in the cloud with the same amount of rigor you approached it on-prem for a generation. And then packet data delivered by an end-to-end hybrid cloud visibility architecture can remove those blind spots, in my opinion. People recognize the importance of packets in the cloud for operations and security. And the best way to do that is by having an effective visibility architecture that expands your entire footprint of what you're trying to protect in terms of performance, security, compliance, and user experience. It's important. So that's it. Thank you for your time. I'm going to turn it over to Raleigh for Q&A, but if you want to learn more about the research, this is a link that you can go to, or you can, reach out to Gigamon and Keysight. They might tell you what they've learned about the research and how it guides their solutions moving forward. And with that, Raleigh, take it away for questions.
Thank you for that great information, Shamus. As Shamus mentioned, the full report is available. Like he said, you can either visit the Gigamon or Keysight websites for more information. I will also include a direct link to the report on the EMA website if you want to learn more about it. Shamus, getting into the questions, how can packet brokers optimize a cloud migration?
So I've talked to people over the years about this. When you're migrating an application to the cloud, the first thing you're going to do is you're going to profile that application in its current environment, probably, to see how it performs, how people are experiencing it, how it behaves in your legacy environment. And then you're going to want to map that to how you architect the application in the cloud. Like, what's the utilization of this application? What's the expectation for end user experience? How often are there peak periods of use of this application that I might not necessarily be aware of? Packet data is going to give you very deep visibility into all that, like how the application operates in your legacy environment, and it's going to guide how you build out the cloud environment. And then once you've profiled that application in the cloud enabled by the data that you are able to deliver to the cloud migration team through your network visibility architecture, then you can help that. You can also test the new cloud environment to see if it meets expectations and for peak usage and things like that by providing the data in the cloud environment. There are other ways to do that are less granular. Maybe you might use like a NetFlow monitoring tool or something that monitors flows, or maybe using like application traces from the DevOps team, and those can solve some of that. But the most comprehensive way of doing that is through the packet data that you can deliver to the cloud migration team through a network visibility architecture.
Thank you, Shamus. The next question is, which companies using more spans instead of taps are switch vendors offering better span features?
I don't think in all the conversations I have with switch vendors, they never mention any improvement to span features on their switches. It's buried in the if there are, it's buried in the product literature. This is not something they're focused on differentiating with. It's a low priority for them, so they're not really making any significant improvements to it. They're making improvements to the overall resources of their hardware, and maybe that stretches, maybe that delivers more resources to the span configuration and allows people are relying on spans more. I don't know. I mean, yeah, switches are horsepower on switches is going up, so maybe that's the case. But I think it's more of a function of increased complexity. As I noted earlier, larger companies are more likely to rely on span ports more heavily. Um, they have so many parts of the network that they need to instrument with a visibility fabric, and budget can only take them so far with taps. And taps aren't aren't necessarily super expensive compared to other things you might invest in your network and your network visibility architecture. But the more places you need to mirror traffic from on your network, the more taps you got to buy, and maybe then it starts to stretch your budget. I think the awareness of the value of taps versus span ports is high, but just resources are limited. Complexity makes it an issue. Um, I think I think that's what's driving it.
Thanks, Shamus. The final question is, do you recommend multi-vendor architectures?
So multi-vendor network visibility architecture, that's people that is, multi-vendor production networks are very common. Um, people using switches and routers from multiple vendors for a variety of reasons. Either it's driven by cost or feature sets, use cases for individual components of the network. I don't know if it's as common. It's not a question I've asked, whether it's common in network visibility architecture, but I am aware of people who are using multiple network packet broker vendors. It's you know it's going to introduce management complexity because I don't think a lot of the vendors in the space manage third-party components. Um, if you have a strong pool of engineering talent that can mitigate that complexity, maybe a multi-vendor solution isn't out of the question. Um, it depends on whether you can balance the challenges of this approach with the benefits. Like perhaps you want a low-cost vendor in certain layers of your network visibility architecture where you can and just rely on the premium vendors for the core components where you need advanced features. You might cut costs on licensing and capex, but you need to watch operational complexity closely. It may add complexity. Um, Perhaps you've got a well-established architecture, but you need new features or functions that your incumbent vendor hasn't supported. Maybe like you've decided that you want to decrypt on a network packet broker and your current vendor doesn't do that or doesn't do it well, and so you're going to move to another vendor. That makes sense, and that might justify the introduction of a new vendor, but you want to, again, keep an eye on complexity. I have talked to multiple companies that have multi-vendor. It's usually a legacy of mergers and acquisitions or a slow switch from one vendor to another that takes them a few years. Um, it could be, but it can also be aimed at keeping their vendors honest, at keeping prices down in some places. But I think it's mostly either a switch over from one vendor to the other or some legacy of a merger of some kind. So, I mean, I don't necessarily recommend it, but I also don't necessarily recommend against it. I think it really depends on your capabilities and whether you think the benefits outweigh the risks.
Thank you for all those great insights, Shamus, and I wanted to thank our audience for joining us today. I will be sending out a follow-up email that will include resources from today's event, so I hope you will check that out. And I hope we'll see you at a future EMA research webinar. Thank you again for joining us and enjoy the rest of your day.